Okay guys, welcome back. Final day of notes for Unit 10. We're going to solve more equations similar to what we did in Day 8. I'm going to skip the first couple. I know it says warm up here. We had examples very similar to that you can look at. But I want to take a look at example 3, or actually warm up problem number 3, because it's one of those more challenging questions. All right, in particular, this looks very confusing. So before I even tackle that, I want to get the cosine isolated. So I'm going to subtract 1 from both sides. Square root 2 times cosine 3 pi x equals -1. And then we'll divide both sides by 2. So cosine 3 pi x equals -1 over square root 2. So now, here's where this is going to come into play. Because notice, x is an element of 0 to 1. So x is in the domain of 0 to 1. Well, here I have a 3 pi x. So what I need to do is I need to take this right here and basically multiply everything by 3 pi. So I'm going to have 3 pi x is an element of the interval 0 to 3 pi. So what I'm doing is I'm not solving for x yet. I'm solving for 3 pi x first. I want to figure out what those angles are. So this one is, again, is a little challenging. Let's think quadrants, ASTC. If you notice here, cosine is negative. Well, where's cosine negative? In the second and the third quadrants. Where is cosine 1 over radical 2? Well, that's 45 degrees, so my reference angle here is going to be pi over 4. But I need that in the second and the third quadrants, and I'm going from 0 to 3 pi. So kind of follow along here. I have to cover this. There's 2 pi, and there's 3 pi. So there's going to be 3 possible angles. All right. So now, 3 pi x could equal pi over 4 in the second quadrant is 3 pi over 4. Or 3 pi x could equal pi over 4 in the third quadrant, it's 5 pi over 4. And 3 pi x could equal, well, basically I need to get a coterminal angle. So I have to go all the way around and then to the second quadrant. So I need to add 8 pi over 4, which is 2 pi, to 3 pi over 4. So that's going to give me 11 pi over 4. Now, to solve each one of these, what we're going to do is basically divide by 3 pi or multiply by 1 over 3 pi. So what does that give me? Right here the 3 pi's cancel, so that gives me 1/4. Right here the pi's cancel, so I've got 5 over 12. And lastly, the pi's cancel, I'm going to have 11 over 12. Now, when you get done, one thing you should notice is that all of these values here should be within this original interval. And they are, so we know we've done it correctly. Okay, let's move on to the next example. So what's going to be a little bit more challenging here is the algebra leading up to the solution is going to be more difficult, not actually the trig component. So remember, our goal here is to isolate sine x. Well, it's in 2 locations. I see a sine squared. So what I'm going to do first, I'm going to subtract 3 sine x over to the left side. That gives me sine squared x minus 3 sine x equals 0. Well, this equation right here is very similar to this equation. X squared minus 3x equals 0. So how do we solve this? Well, you'd factor out an x, and that gives you x minus 3 equals 0. And then you'd set each factor equal to 0. So I have x equals 0 and x equals 3. Well, we're going to do the same thing, except instead of an x, it's sine x. So we'll factor out a sine x. That gives me sine x minus 3 equals 0. Set each one equal to 0. That gives me sine x equals 0 and sine x equals 3. Well, I'm going to talk about this last one here. Sine x equals 3. There's a couple ways you can think of this. Think of the unit circle. Think of your sine graph. Can't go above 1, can't go below -1. So once you get a sine value that's above 1 or below a -1, there's no solution from that particular equation. So on the left side here, I've got sine x equals 0. Well, anytime you got 0 or a 1 or a -1 with sine or cosine, you're thinking unit circle. Sine is the y value. So I like to think up and down. On the unit circle, where's the y value? 0, here, and here. Okay, well, if you look at our domain, it's 0 to 4 pi. So if I start at 0, I'm going to have 0, pi, 2 pi, 3 pi, and 4 pi. Now, what's very important is that you notice the brackets, so that is inclusive. So my solution would contain all of those angles. 0, pi, 2 pi, 3 pi, and 4 pi. Sometimes what you'll see here is parentheses, or you might see a less than symbol, so you wouldn't include maybe one or either of those end values. All right, next example. So once again, I know this looks confusing because we're not used to seeing a cosine in a quadratic, but this equation is no different than 2x squared plus 3x minus 2 equals 0. So how would you solve this one? Well, you'd factor each one. 2x and x. Signs are different. It's got to be a 2 and a 1, so it looks like it's going to be this, plus minus there. Yep, check it with FOIL. So what I get over here using a shortcut, x equals positive 1 over 2, and here you get x equals negative 2. I'm going to do the same exact thing, but instead of x, it's going to be a cosine x. So I need to factor. We're going to have 2 cosine x, and cosine x is the first terms. I'm still going to have my 1 and 2. So again, you can check with FOIL. I get 2 cosine squared to start. Then I get plus 4 cosine minus 1 cosine minus 2. So you combine those like terms, and yes, we get the above equation. So now what this says is cosine x equals a positive 1/2, or cosine x equals negative 2. Well, remember what we just discussed. Cosine x can't be below a negative 1, so from this particular equation, there's no solution. Now over here, I've got cosine x equals 1/2, so I'm thinking ASTC. I have to pay attention to my domain, 0 to 2 pi. So I'm just going around the unit circle one time. Where is cosine positive? Here and here. So what I'm going to do is I'm going to say, all right, I'm going around one time, and every one of those angles that we hit, you write down that's part of your solution. So where's cosine 1/2? You've got to know that's 60 degrees, so that's pi over 3. Pi over 3 is just pi over 3 in the first quadrant. In the fourth, we have 5 pi over 3. And that's your solution. Okay, this next one, I see 2 different trig functions. Well, one thing that we cannot do, all right, let me give you an analogous equation over here on the right. This would be something like yx equals square root 3x. One thing you cannot do, you can never divide off a variable because you lose a root. So I can't divide both sides by cosine. What we're going to do is we're going to get everything to one side. So this is yx minus square root 3x equals 0. Now what I can do is I can actually factor out an x as a GCF. And I have y minus square root 3 equals 0. So now I can still come up with 2 equations. The variables are different, but I still have 2 possibilities. Either x equals 0 or y equals square root 3. So now we're going to do something similar with the trig functions. So I'll subtract over square root 3 cosine x. Now, what do they have in common? Well, they both have a cosine x. So let's factor that out. And I'm left with tangent x minus square root 3. And all of that equals 0. So now, the zero product property says cosine x equals 0, or tangent x minus 3 equals 0, which just tells me tangent x equals square root 3. So now, seems like we're going to have a lot of solutions here. I'm going from negative 2 pi to 2 pi. I want all the values where cosine x equals 0 and all the values where tangent x equals square root 3. So for the first one, cosine x equals 0. Again, I'm thinking unit circle. You can think of the trig graph for cosine, whatever's easiest. Cosine is the x value on the unit circle. Where is the x value 0? You go right or left 0. Well, I'm talking here and here. And remember, I'm going from 0 to 2 pi and from 0 to negative 2 pi. So that's going to be a few angles. I'll write them down over here. So I'm going to start at 0. Okay, it's not 0, it's pi over 2. Then you go around to 3 pi over 2. Okay, and then if you go the negative direction, guess what? You're just going to have a negative pi over 2 or a negative 3 pi over 2. So I'm just going to put plus or minus in front of both of those. So now let's deal with tangent x equals square root 3. Well, it's positive, so now I'm talking quadrants. Tangent's positive in 1 and 3. And again, remember, I have to go 0 to 2 pi, and then I have to go from 0 to negative 2 pi. Well, you need to know your reference angle. Where's tangent square root 3? That's 60 degrees. So that's going to be pi over 3. As you go around the unit circle, pi over 3 in the first quadrant is pi over 3. The pi over 3 family in the third quadrant is 4 pi over 3. Now if we go the negative direction, it's not quite as simple as cosine. I go beyond negative pi over 3 into the second quadrant, into the third quadrant. That's going to be negative 2 pi over 3. And then as you go around all the way to the first quadrant, that's going to be negative 5 pi over 3. So a lot of angles satisfy that equation. Okay, so I'm going to stop this part of the lesson here. There are 3 more examples that I'll be doing, but just to keep the video a little bit shorter, I'll stop here. Please watch the second video for this lesson before you guys attempt the homework, and I'll see you in a little bit.